Hi student, in this video lecture we are going to study the triadic curve. This is the one more new concept related to computer graphics. First of all, this triadic curve is also called as the triadic Koch curve. Triadic Koch curve. So when we considering this curve to draw, or it can be when we're drawing the triadic Koch curve or Koch curve, we have to start with a line segment, and then this dividing that line segment into three equal parts. After that, we are replacing the central third part by the two adjacent side of an equilateral triangle. So equilateral triangle. So when we considering this triadic curve or Koch curve, we just consider the three lines, right, or three figures. First figure, this figure we consider this is the line, right, and this is your original segment, that is with a line segment. So consider this line. Then we consider this is the second, right, this is the first approximation considered, and then we considering the third approximation like this one. Right, this is your second approximation. Here we consider this line divided into three different parts like this one, right, and we consider the trimetry, and then we consider this image, and we consider these are the points or the vertex of these images, right, or these are the vertex with this respect to this curve. So in that, right, when we considering this figure, okay, when we considering this curve, right, this curve whose ends coordinates are same that of the original segment, but is built of four equal length segment, each 1/3 the original length. So that means when we considering this line is divided into three different parts or same size part like this one, right. Then we considering this adjacent equilateral triangle. This is the equilateral triangle for dividing this, and when we considering this gives us the curve whose end coordinates are same that of, so these coordinate are the same, which is considered as your original segment. And when we replacing these four different parts, right, and these different parts, these four parts having the equal end sides, so this you consider this having the same size, which is for this, which is say having the equal distribution from this your original segment. So the new length of the curve will be 4 by 3 of the original length. That means we have to repeat this process for each segment. That means each of the 4 segment. That means we just again we implement this. So when we considering this figure, consider this is the A, this is the B, and this is the C. So when we considering this is the figure B and C, this is the first and second approximation of the respectively. So when we considering the after the approximation, the length of the curve because of after the second approximation, the length of the curve because of the 16 by 9 times of the original. So when we considering this length is the 16 by 9. So when we considering this Koch curve, right, this Koch curve having some properties, like first property, length of the first one is the length is the infinite. That means the length of the Koch curve is infinite, right? Next property, it does not deviate much from its original shape. Third one, we reduce the scale of the curve by 3. We find to also look just like the original curve, that is the one, original curve, that is the one, but we must gather for such curve to make original. So we can say, right, 4 is equal to 3 df, right? And when we considering the df, so solving for this df, right, we get like this one, df is equal to log 4 by log 3. So therefore df is equal to 1.26. So this is the solution, or after this simplifying the equation, we got this df is equal to 1.26. Therefore the Koch curve topological dimension is 1 and fractal dimension is 1.26. So this is all about the Koch curve.